Guys, so I ran into this problem the other day. It's kind of an interesting one, and what intrigued me more was this follow up basically. So before we talk about this follow up, let's just quickly go through this definition. So we're supposed to find a majority element. We're given an array or a list of numbers, right? So those are integers basically, and we're supposed to find a majority element. Now the definition of that is there will be one element in this list, and we can always assume that there's one which is going to exist from the given input, which appears more than n over 2 floor value of that times, right? So if you take this one for example, the length of this array is 7. So 7 over 2 is 3.5, floor value of that is 3. So there's one element, in this case 2, which occurs I think 4 times, right? So there's 2 and there's this 2. 4 is greater than 3, so that's the result. Obviously 1 is not the output here because 1 only appears 3 times, but the majority element will appear more than that, right? So when I look at this kind of questions, the first thing that comes to my mind is basically to take help of a data structure like hash map or Python dictionary, right? So what you do is you basically iterate through this entire list and you create the count of each and every element that appears, and then again you go through the dictionary to find out who stands out, right? uh, the frequency of the element that appears more than the definition is basically your output. Now if you come to this follow-up, it basically asks you to solve this problem in linear time, which is okay. So you're going to go through this list only once and in one space, which is basically a constant space. So that rules out all the leverages that we have, right, from dictionary and hash map. So we're not supposed to use that. In that case, how do we go about it? Now to solve this, there's this apparently there's a popular algorithm called I think it's called Moore's voting algorithm. I didn't know about this until I came across this problem. And what this algorithm tells is basically is there's always going to be one element which stands out, even though there are other elements uh, who are practically trying to shoot the majority element down, right? So what do I mean by that is, if I really talk about the algorithm, so what we're going to do is we're going to take a count which is set to 0 initially. We'll discuss more about it in a second. And then this is our potential output, which is set to a variable called result. And I'm going to initialize this with none because I hate to initialize it to 0, because 0 can also be a potential output, which is not the case. We don't really know what are elements that are present in this list, which is given as an input to us, right? So I'll stick to none. I know the definition says the output is integer, and because it says that it's safe to assume that there's always going to be majority element, so my output will never be none, right? So it's safe to set this to none. Now what we really want to do here is we are going to iterate through this entire list only once, so for n nums. Now if my count, we're going to explain it in a second, is set to 0, I mean if it's already 0, so what I'm going to do is I'm going to switch my result back to the new element, because this can be my potential output now. Why? Because so far whatever I have, let's say, come across in the list was not worthy to be considered as a majority element, because every other element in this list that we have let's say come across so far has reduced the count of the potential majority element. And if that's not the case, what we're going to do is, if count is not set to 0, it means that we're still potentially iterating through the majority element, because count is not set to 0 yet. So we are going to increase the count by one more, because so let's say this is set to 1 if n is equals to let's say result that we have set in the previous iteration, else I'm going to take the count to 1 down. And in the end of the day, what is going to happen is we're going to just return the result. Now what we're going to do is we're just going to take this as an input and try to see how this algorithm works. So initially my result is set to none, my count is set to 0, so this is the first element that I encounter. So right now my counter was 0 obviously, so result will be set to 2. Oops, sorry. And count is 0. Now what I'm doing is count is, so what we're doing is we're basically increasing count if my n is equals to result. So obviously at this first iteration 2 is set to result already, so this will hold true and my count will become 1, right? Then the next 2 comes, so n is still equals to result. Obviously this is not going to be iterated because my count is non-zero now. This is set to 1, so it is not going to get iterated. The next value is 2, which is equals to 2 again, so my count will go 2. Then I encounter 1, so that's where, right, so this is one potential element which is going to shoot the majority element down, because 1 is not equals to the result that we already have set to, which is 2, so we're going to take count down, so now it becomes 1. Then we go to the other one. So this is still not equals to result, right? So we are going to take count to 0. Now for this one, because my count is set to 0, so my result will become 1 now. Well and good. Now we come to 2. What 2 does is it basically, again, right, takes the count to 0. So result was 1. It already became 1. Now it became 0 again thanks to this 2. And then this another 2 came in the picture. Obviously this is going to get iterated as 0. So my count will become 1 and my result will become 2. And that's going to be my output. So let me just quickly submit this one. Yeah, this algorithm works. Thank you guys.